Try to do a better cell than me, huh? Okay. So this is the galvanic cell. Or electrochemical cell. This is what this is. I need not write it because you know it very well. Okay. So this is cathode. This is anode. See whether it is electrolytic cell or electrochemical, irrespective of the charge, cathode will be always on the right and the anode will be on the left. Okay. But in electrolytic cell, cathode is negative and anode is positive. In electrochemical cell, cathode is positive and anode is negative. I told you that. So this is positive electrode and this is negative electrode. So electrode could be anything, huh? So say for this case, this is zinc and this is copper. And we have taken here zinc sulfate 1 molar and copper sulfate 1 molar. Okay, so now when you talk about the electrochemical cell, every time it's not possible for us to draw it. Then how to represent electrochemical cell? So representation of electrochemical cell. Okay, so we'll write it just as it is given like this. We write from left, so we'll see everything from left. So left, what do you have here? First is the anode. What is the anode here? Zinc. So I can write here as a this one. So this one, I'll write it. How to represent this is we know. This is what? This anodic half cell. this is cathodic half cell. So how to represent anodic half cell? Anodic half cell we write, see from right, left. First we have zinc. We can write zinc. Okay, then we can put 1 semicolon, and what we have now here? Zinc ion is there. We'll write here. Okay, or we can write it as zinc Zn2 plus. Then I will follow this. Okay. Now cathodic half cell. What we have left hand side? See, this is on the right. Left hand side, what you have? We have here now copper solution. We can write here for Cu2 plus semicolon and C. Or what we can write here? Cu2 plus C. In between, what we have? In between, we have salt bridge. Now I'm going to write the complete set. Okay. So I'm going to write. So now I'll write it like this. So the galvanic cell is here. Zinc Zn2 plus. See, these two vertical lines stands for this salt bridge. Cu2 plus. Or you can also write their concentration. Or what you can write here, what is the concentration? 1 molar or 1. So we'll write now here Zn2 plus 1 molar is the strength of the solution. Then Cu2 plus 1 molar. This is the way you represent a galvanic cell. But your book also will find they may ask you to represent some cell, other galvanic cell. Huh? So the example of other galvanic cell. Huh? Other example. Say it is copper silver nitrate cell. See here. This is always cathode. Sorry, anode. Left hand side is anode, and this is cathode. So in this case, what will be the oxidation? This anodic cell or oxidation half cell? You must know, because we know electrodes are always dipped in their own solution. So what is the anodic cell? It will be Cu. This is the electrode, and this is the solution. reaction, half cell. Okay, so in that case, it will be silver ion. So what will be this one now? Silver plus aqueous. This is the one. This. And what will be the electrode? Silver. This will be the electrode. Please write down now the cell. Cell representation. Please write. I told you in between you have to put solid bridge, and for solid bridge you have to put two vertical lines. Plus CO2 plus aqueous, then Hg plus aqueous. Good, very nice. Okay, this is the second. Then third example I'm going to write. Zinc HCl. Okay, zinc and HCl. So what should I write now here? It is this. Then it is HCl gives you H plus ion. Then it will be H2. Okay. So here hydrogen is gas, we know. So in that case, what should I write now here? So non-metal hydrogen does not conduct electricity. So in that case, what we put here? We put platinum as a electrode. So this is the one. So now write the cell representation. So we write now here. This is the one. Now you will write one by yourself. Nickel, copper sulfate. Right. That I will not write. You only have to tell me.
Sir, nickel solid Ni brackets S
Then
bar Ni plus 2 aqueous
wait, nickel S. Then this vertical line. Then
Ni 2 plus aqueous,
then
2 lines,
then
Cu2 plus aqueous,
CO2 plus aqueous.
1 line Cu solid.
Yes. So this is the way to represent an electrochemical cell. Only whenever you use hydrogen, in that case, you have to put on platinum. Why? Hydrogen being non-metal and gaseous, it does not conduct electricity, so you have to use a inert electrode like platinum. Okay. So let us now know electrode potential. Gitanjali, you have done electrochemistry in your school, na?
Sir, can you repeat? I couldn't hear.
Did you finish electrochemistry in your school?
Yes, sir.
Acha. So any other who has done electrochemistry in the school? Any other student? Please tell me. Potential and electromotive force, which we call it in abbreviated form as EMF. This can be written in capital as well as small letter also, no problem. Okay. Now, what is electrode potential? Let us first try to understand. See here. I have put a metal. This is an electrode only, metal. And it is dipped in a solution of the same ion. Okay. What you have here now? M n plus, because we do not know what is charge. So I have written Mn plus. That is, electrode is being put in a solution of the salt of the same metal. So what are the things are going to happen? There are three possibilities. Okay. Either this metal will be indifferent to the ions. It will not bother. Neither the metal will bother for the ions and ions will bother for metal. Suppose say you have, say next year you have gone to a new school, college or anything, institute. So there you went there and you are standing in the queue for admission. Okay. Say it is you, okay, and this is another person. As you don't know each other, so you will not look at anyone. You'll be indifferent. Okay, you'll be indifferent. So here metal atom will be indifferent to the metal. Second, you may find that maybe that this person has to talk to you, but you don't want to talk because you do not know. Why should you talk? Okay, so in that it is like this, but you do not know. Okay, so you do not know, so you don't look like this. So this person may like to interact with you, but you are not bothered. So in that case, this metal atom may like to interact with the metal atom. Okay, here I can write metal is indifferent to metal Na plus aqueous. In this case, metal may like to interact with the metal. And third possibility is this. This. Okay. But you may look at this person. This is also another possibility is there. So in that case, what happens? Metal may be indifferent, but metal ion may like to interact with this. So these are the three possibilities are there. When you dip a electrode in the solution of an electrolyte made of or the salt of the metal. So these are the things can happen. Okay. So see here how the metal is. Suppose I'm going for this. How the metal? See, this person is started smiling. Okay. So in this case, what may happen? This metal may lose electron to become metal and plus. But I told you, we never write any equation negative sign. What I'll do, just to follow the convention, I transfer it to the right hand side. So what I'll write, what should I do? I'll write it like this. M N. See, the loss of electron is called oxidation. So in that case, I'll write everything, electrode potential definition, everything I'll write. So in this case, what is happening now? Oxidation takes. Now let us go for the third one. In third one, what will happen? Metal ion may like to take type electron to become what? M N. Sorry, it has because N electron, then it has become no metal. So this is the third. So what happens now here? Addition of electron, what we call it? We call it reduction. Okay. Anyway, you need not write all these things. If you wish, you can write or need not write. Huh? All right. So these are the three possibilities. So what will happen in this case? In this case, it is if you know write it. There is no interaction. What happens in this case? Metal atom lose electrons or undergo oxidation. What happens here now? Metal ion gains electron or undergo reduction. All right. So you write up to this much. This one you don't. That every atom has electron, and electrons are associated with an electrical charge. So metal has all the number of atoms. Whatever the number of atoms supposed to be present in metal, it is there because metal is electrically neutral. But when you go for metal ion, the electrons are less. So obviously, in that case, the charge also will be less. So what is electrode potential? It is the differential in there. It is the potential difference between the metal and the metal ions present in the solution. Okay, so let us write down now. Electrode potential. Electrode potential. The electrical potential difference set up between the metal and its ion present in the solution is known as electrode potential. Then potential and to reduction potential. Now, what is oxidation potential? The tendency of an electrode to lose electrons or to get oxidized is called its oxidation potential. Now, the oxidation potential give the tendency of an electrode to lose electrons. Higher the value, faster it will lose electron. Okay, so what is going to happen now here? It is ms m n plus aqueous and air. Okay, so this is the common one. Example, zinc. Zinc aqueous plus 2. Now hydrogen. See, hydrogen can gain electron and as well as lose electron. This is a unique element.
Done, sir.
So now we'll go for reduction potential. Therefore, it measures the tendency of an electrode to gain electron. So what should I write now here? I'll tell you something very interesting. Huh? See, hydrogen molecule gives electron, hydrogen ion takes electron. Finish it and I'll tell you. Third, electron is generated by the loss of electron of the atom of anode. I've shown it. And ultimately, the electron travels to the outer circuit and reaches cathode, that metal rod. Okay, metal rod. Now see, you can see these two. So see here. This is convention by you. It is in your right hand side. So this is cathode and this is anode. So the atom from here lose electron on the surface of the electrode and plunges into solution. Then the electron travel this way. Say this is the where. Then where it comes here and reaches here. Okay. Now after reaching, where the electron goes? Electron goes to the ion. So ultimately, though we say this is the cathode, but ultimately electron is reaching home. Electron is reaching to the ion. So actually, ion is the cathode and anode is the metal. So we have given you ion. Here we did not write because ion, the cathode brings the electron. Just like that, your father goes to market, spends money, and buy vegetable and fish and different food items. It is being brought to you, brought to your home. Mother cooks it. Ultimately, who eats? It is you. Who loses the money? Father. Or it may be your mother also. Okay? Then ultimately, who gains it? It is you. All right? So in that case, these ions are actually the cathode. See, for every flow, there is a source. And ultimately, the place where it goes, we call it sink. And source is always followed by the sink. So sink here is the cathode. Now, we have found that the electrons are flowing. From where it will flow? It will flow from anode to cathode. It will flow from anode. I'm not drawing it. Anode. Here you have the electron. And it comes. Okay. This is the beaker. This is another beaker. This is the solvent. And it comes. So this is the cathode. Okay. This is the electron is flowing. Electron is flowing. So I told you in this case, the flow of electron, any flow of this flow of electron, we call it electronic current. But this is not electricity. Why? Because this is negative and this is positive. We always seen from our childhood, things move from positive to negative. Okay. So what do you say? What did I say that day? That by convention we say electricity flows from positive to negative. Though we know electrons flow from left to right, but we say no. Electricity moves from right to left. Though it is nonsensical, but we have to follow the convention. Okay? Sun rises in the east and sets in the west. In the sky, do you find it is written there east? Huh? It's not written. So it is by convention. We say the sun rises in the east and sets on the west. So it is by convention we say east. All right. So here also we say by convention. Why? Why from you got the convention? Because we know everything should go from higher to lower. What is higher? Higher is always positive. What is lower? Is negative. Okay. Now why should they flow? Any substance will flow if there is a gradient. If the gradient is there, then only it will flow. Others it will not flow. In a lake, water does not go anywhere because surface is same. Okay. Why the water flows from mountain to the river? Because it is the mountain is on the higher altitude and the river is at the lower altitude. So water flows down. We cannot say the water from river is going up to the mountain. Clear? So that the potential difference which is sets up between two electrons. This is more, this is having electron and this is having less electron. So the flow of electron occurs. And when the flow electron of the electron occurs, we know that that electron helps you to generate electricity. All right. So that difference between the two electrodes, in one case it is oxidation potential, in other case is reduction potential. So the difference of potential difference between these two is called electromotive force. Why do you call it electromotive force? See, without motivation, nothing moves. Without motivation, nothing moves. Why raindrops falls on the ground? What is the motivation? In that case, it is the potential difference. Okay? Without motivation, nothing moves. Here also, why the electrons move? What is the motivation? Because there is a large difference of potential difference between two electrodes, so they move. So we call this to be electromotive force. So now I'll write down electromotive force. Electromotive force or EMF. The potential difference between the standard. Okay, I first of all, then I have to tell you what is standard. See, we told you electrode potential, and what is standard electrode potential? Standard electrode potential. Once you say standard, that is, you have to set the standard. Electrode potential, you can measure it at any concentration, at any condition, at any temperature. So, what is the standard electrode potential? Electrode potential measured for an electrode dipped in 1 molar solution of the electrolyte of same metal at 298 Kelvin. Sorry, EMF. Electromotive force or EMF. Okay. See. No. Before that, I'd like to tell you. See here. See. Before I like to tell you that oxidation is reverse of reduction. Oxidation is reverse of reduction. So let me write it here like this. Say it is MS N plus was N. All right. So when this is losing electron, say here the energy is E. All right. Energy is E. And when it gains electron, because you have to force electron to go, in that case, what will happen? The value will be same. But only thing is that when it loses electron, magnitude of both of them will be same. All right. So if it is minus, sorry, if it is plus, why? Why it should be plus? Because you have to force the electron out. Why? Why you have to force? Because you know that number of electrons and protons are same. And in that case, what was happening? Because to remove the electron, the electron has to overcome the attraction of the nucleus. Huh? So in that case, energy must be supplied. And when the electron comes back, in that case, nucleus is pulling, so electron doesn't have to do any work. In that case, it is minus. Huh? So what should I write? Oxidation is reverse of reduction. So whatever the value of standard electrode potential for oxidation the value will be same for reduction, but the sign will be opposite. We should know. 3 times I've written 3 7. Because this small thing is not being given in your book. Electromotive force or EF. It is the potential difference between the two electrodes in an electrochemical cell. It is indicated by E0 cell. All right, so I'll write down here E0 cell. So we know the cathode is positive. So I'll write down here E0 cathode minus E0 anode. Okay? E0. Or we know that cathode is always on the right and anode is always on the right, on the left. So we can write down for E0 cell is equal to E0 right minus E0 left. Okay.
Done, sir.
Okay. So now we'll try to see that how, because simply theory will not help. We should be able to find out the standard electrode potential, or there is a oxidation potential or reduction potential. We have to find out of different elements. Okay. Now, see. Now you suggest me. Suppose, say you are doing a survey. So you have gone to a hilly place, okay, and the mountain is there, and after some time a deep gorge. So this is sea level. How do you find the height of the mountain? How do you find it? How will you find the height of the mountain? Huh? How do you measure your height? Could you understand my question? So many of you cannot reply. Hello. Can you hear me? Huh? Are you able to hear me? What happened?
Yes, sir.
Then why you are not replying? How do you measure your height?
Measuring tape.
Measuring tape. How will you measure the height of the mountain? Huh? See, different peaks are there. Do you not find if there at Mount Everest is 28,000 something feet? It is they have measured by the scale only. Huh? So they should measure with the scale. So it is 28,000 say 456 feet. If they are measured by a scale, they did not take, they have such a long scale is not there, but they have different techniques, and by that way they express in the form of a scale. How do we measure this gorge? How do we measure? Hmm? They will measure by the same scale. Only thing is that when they express it, because it is sea level is what? 0.00. Huh? So in that case, they'll put positive, and there they'll put negative. Negative. So see, there is a place in Pacific Ocean. If you drop Mount Everest, it will simply sink. In near about 5 kilometer depth is there. Okay, so the same scale is being used. In case of this gorge, it is being expressed below sea level. Below sea level, moment they say below sea level, actually should be negative. But generally with common sense, we do not put negative. We say sea level. Above sea level and below sea level. So we know that we have two types of electrode. One is losing electron, which is an anode, and one is gaining electron, which is called cathode. So we should be able to measure their oxidation potential as well as reduction potential with the help of the same scale. Same scale means what? We have to use a electrode. This electrode can either give electrons when you measure it for cathode, that electrode will behave as the anode if you want to measure the electrode potential of cathode, and if you want to measure the electrode potential of anode, same substance we should be able to use as cathode. All right. So we know there are elements which either lose electron or they gain electron. There are very few elements are there which does both, which gains electron as well as lose electron. And one of them is hydrogen. I've shown you hydrogen gas loses electron. In that case, you can use that as an anode. But hydrogen ion or proton, it gains electron. In that case, it can act as an electron. So now we are going to discuss standard hydrogen electrode. In abbreviation, we write SHE, but many a time we write simply without full stop also we write SH. So standard hydrogen electrode is being made in a special glass container. Where you find where a platinum wire is being sealed inside, and it has a platinum wire. So this is platinum wire, and this is platinum wire. Okay, and it is being coated with platinum powder, which is known as platinum black. Platinum black. Okay, and it is dipped in a solution of 1 molar HCl. Now, this also contains a glass tube through which dry and pure hydrogen gas is bubbled at 1 bar or 1 atmosphere. Because if you go for SI system, you have to go for 1 bar. Okay, so when hydrogen comes out, what will happen now? So this hydrogen will come out like this. So standard hydrogen electrode is being represented as H plus 1 molar, H2 1 atmosphere or 1 bar, But how the electricity is passing to platinum? So this is this. And its standard electrode potential is considered, we only fix it, is considered as 0.00 volt. One more thing for entrance. Difficulty, or we write demerits of using standard hydrogen. Okay. It is very difficult to maintain 1 molar concentration of acid for long time. B. It is very difficult to maintain 1 atmosphere or 1 bar pressure of hydrogen gas. Okay. Third. Platinum gets poisoned. Platinum gets poisoned easily. Easily in presence of even trace amount of impurities. So these are the things. This anyway. So, sorry, you just see. Somehow this your book is somehow quite about this portion, but you should know. খুব বড় লালি যে কোম্পানিতে কাজ করছে ভেরি বিগ ও
Done, sir.
আমি অফসেট okay. Now, if it is so, okay, finished. We should know a little more. একটা জিনিস আমার মাথায় পরম আমাকে বলেছিল মুখে দুই কথা আছে
Sir, I've already finished to write.
Oh, then why you are keeping quiet? Okay. Now, see, when these electrodes are having so much problem, then we should have an alternative. Okay. Therefore, this is only for your entrance. Therefore, some other secondary reference electrodes are used. What are those? Saturated calomel. Hey, don't get scared by calomel. Huh? Calomel is mercurous chloride, Hg2Cl2. Okay? Mercurous chloride. So I'll write down here. Hg. Hey, don't get scared. I told you only for entrance. Those who do not want to appear entrance, forget. Okay? S means okay. Now, potassium chloride saturated. Okay? It has a value of E0 value is 0.245 volt. Right? For hydrogen is 0.00, it is 0.245. So whatever the value is there, you subtract or add, finish. Okay. And second one is 1 normal calomel. Okay. So here you don't take saturated, we take 1 normal. So here it is same only Hg, Hg2, Cl2. Okay. See, solubility of mercurous chloride is very, very less because of that. Yeah, potassium chloride is 1 normal. Okay, here E0 value is 0.2800. Then I will use this one. This is only for your entry. Okay, so today I will not go for it because if I start finding out determining the electrode potential, then it is going to take around 40 minutes. So today I will not continue. So I shall discuss with you on coming Thursday. Okay, good night.
Bye, sir.